which is probably likely. So this is essentially a Python routine to do the same thing. Right. I invoked that using, well, first of all, I ran sudo. If I don't know if, oh, it's only running 2 and 3, so it'll probably run without root access. Within the IDE, it's possible to take a Python routine. So there's this magic, what's called a shebang at the beginning, which is the comment mark with an exclamation point followed by a program to run. Mm-hmm. If you just run that from bash, it's going to run that program and then use this text as the program to run, to essentially provide as an argument. So that's essentially the same thing as typing Python 3, right? Or I guess I didn't need to run sudo because this is not using the PRU one. Oh no, it did. The setup failed. Right. So it is possible. This script needs to be updated to be run from the IDE. It's possible to run Python scripts from the IDE, but it's going to give two issues here. I think the default runner might be Python 2, and so I think that's one error. It also won't run as root by default, so you would have to do something to elevate its privilege to root. So in general, just don't use the run button, but you can make it work. And if you care enough about it, I can help you get any program to run under the run button for folks. But if you just go into that directory, right, you can just run these sets of Python examples. Button. Uh-oh. Adafruit BBO is installed on the new version of the tool, so we need to fix that. The fun one is this balance. You got motors, the motors connected into 2 and 3, and encoders connected to 2 and 3. Anybody got that all set up? Nobody has it all set up on their Beaglebone?
Not ours.
Do you have your whole hardware config set up? Plug it. Go ahead and plug in your battery.
I'm assuming the motors are in the right spot, 2 and 3 as well.
Yeah, they should be in. Motors should be in 2 and 3, and encoders should be in 2 and 3. Go ahead and plug in your battery because the motors won't drive without the battery. There's one program which you could just run, just like the C program, rc_balance, or you can do. There's balance.py. See, there's a Python version of the same balancer.
Oh.
The way the balance application expects to run once you're balancing, that's good. You lay it on its back. There's an LED that'll go from red to green, telling you that it's ready to stand up, and then you stand it up.
Wait, so that's
At least, are you running the Python version or the C version?
the C version.
Yeah.
So I can just that.
Are you still connected?
Yeah.
Run it?
So if you run it, the light will go green when it's ready to balance, and then you can set it up and balance it.
Yep.
I think this Python version actually has a thing where you can start steering it with
Well, I don't know what this is supposed to be.
with the console.
No, there's no
As
need
well.
to connect this. The two motors are already small.
Anyway, it's a nice little
It's already cool.
like the balancing here is done in Python, so it's a nice little control example that's entirely in Python.
Hold that where don't unplug it.
Yeah, I don't know. Are you connected over the network?
The IMU one's interesting, I guess. So So again, looks similar to the C program output, but here it's written in Python.
Oh, is it working? Kind of.
Celebrate back.
You have that. Sorry, that little cable is connected because I was doing a stepper motor example.
Oh, okay.
That's why I've got that cable on there.
I don't think there's a good.
So
stepper
start by
motor.
laying it on its back until you start the routine. Okay, you just gotta move your computer somehow to.
It's like laying on the.
So start laying on its back. Are you running the Python one or the?
The Python one.
Okay.
Yeah.
So yeah, so that one you push enter to start balancing. No. So there we go.
Okay.
Gotcha. Okay, cool.
Finally.
So that's using the IMU. It's using the encoders. It's using the motor drive.
Controls.
And then of course you can change the phi set points. You can actually get it to drive forward, drive backwards, turn left and right.
Gotcha.
So you can give it set points
Are you serious?
in the application to have it actually drive around. The most common failure mode I've seen in these is those optical encoders will pop out. Like sometimes you get them knocked out physically to read back the encoder values. So you just kind of, if you have one that's not balancing properly, I would look at that. You could. It's pretty robust at changing the mechanicals on it. Like you can add a little bit of payload. These aren't going to carry your 20-pound requirement, right? That's the huge limitation of these. Plus, it's draining the battery the whole time it's standing. But I've in practice these batteries and this. Oh, you're driving it around with your keyboard.
Yeah.
See that? Is that they, they run about 6-8 hours on a charge. Or longer, but that's if you're driving it around a lot. The other examples inside of the examples folder, there's a fair bit. The cookbook is some nice. This is a book that Mark Yoder and I co-authored. Really, Mark wrote, and I just kind of helped him with the examples.
Okay.
So one of those is.
Right?
Yeah. So one is this flock demo, which I think is kind of nice. You can get the details in the book. Come on.
One demo.html. Do we double click it?
I did, and then it proceeded to lose my network connection.
I'm not clicking mine.
Maybe reconnect the Wi-Fi.
So it's going to read this. Let's see what this one does. I have to refresh my memory of what this does. So P936, I think that's an analog input signal. I don't think it's the one I have anything wired up. Testing some of this stuff, so let's see, analog reads. Oh, I guess it would help to print it. No, it would print it. Node is a pretty slow interpreter getting started up. Once it starts running, it runs pretty nicely.
So,
Okay, so it's just whatever analog voltage is right now, it's just thinking it's 0. So I need to try to find some input I can change.
So if you just called a node a command in node syntax, is that what?
That's what I did. So I invoked the node interpreter from the command line. So -PE means print output, and E means evaluate this statement. And I used my Bone script library. So require brings in the library. Then the dot specifies that I'm using a member of that object that's returned by the require. The member I'm using is the analog read function.
Where do I see a list of the members that I can find in BoneScript?
Using JavaScript, I can do it this way. The better way is probably to go to the GitHub repo or go to beaglebone.org/bonescript, which ultimately should probably get back to the GitHub repo. But this is just printing the object returned by require will tell me its members. So some of these are constants, right? Like input pull up, right? These are just constants that are defined, but other ones are functions. So like there is an analog write function, analog read function, and I've actually defined so there's the function I've actually defined in the object also the arguments that it takes so it's a little bit self-documenting.
Okay.
So I can do it's for me it's a convenient way to do analog reads. The most important stuff here is the pin mapping, because I don't remember on the top of my brain which ADC P936 is. My source code here is using Java, is using the BoneScript library.
Speaking of this, checking what pins we can use for inputs and outputs, analog and digital. Where is the proper place to go with that? I think there's a reference on GitHub, but some were not. Some pins didn't work out.
There are so the easiest place. The easiest thing I've got for trying to do this like trying to figure out pins, it doesn't this doesn't give you the mapping for Beaglebone Blue specifically for the headers, but it does give you what the current pinmux mode is on any of those given pins. Right, so it's a little bit like config pin, but it does it across the whole array of pins.
So the names are something like 9.27, and how do I find pin 9.27?
Right. So a lot of this information is encoded in BoneScript. So like for my super lazy way, like here I wanted to do an analog read of that pin. I can also do a think of what the function name is. Since we printed them all out up here, we can do get something like get pin or get pin mode. So I've got if this wasn't so slow to start up. Okay. Node, I'm just going to start an interpreter. Node itself takes so long to start up that it's kind of being a pain for me every time I want to run one of these different commands. So I'm just start node and stop restarting it all the time. So var b equals require bone script. Now, bone script, I have my own stuff in bone script. My own kind of names of pins for all of the pins on the on Beaglebone Blue. How do I'm trying to think of where I documented that even.